Writing linear functions. Our objective is to use slope-intercept form and point-slope form to write linear functions, as well as write linear functions to solve problems. Why learn this? When you play Monopoly, it's easy to calculate the rent of most properties by looking at the selling price. Let's start by writing the slope-intercept form of the equation of a line. So, write the equation of the graph line in slope-intercept form. To recall back, slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. So, let's look at our slope. So our slope, we have a negative slope because the line is going down, and we're going down 2 and then to the right 5. So down 2 and to the right 5. We're keeping our y and our x because that's our input and our output values. And then we're going to add on our y-intercept. So where does the line cross the y-axis? At 2. Alright, so the slope formula. When you're given 2 points on a line, the slope is the ratio of the difference in the y values to the difference in the corresponding x values, or you can think of it as rise over run. So the change in the y over the change in x. And that will give you your slope for rise over run. Alright, so find the slope of a line given 2 or more points. So we're going to start with A, and we can select our y. So we have y minus y1 over x minus x1. The smaller numbers on the bottom are just to denote that the two y values are from different coordinates. Okay, so we're going to have x, y, and x1, y1. Alright, so we have negative 2 minus 2 over 3 minus negative 1. Negative 2 minus 2 is negative 4, and 3 minus negative 1 is like saying 3 plus 1, so that's over 4. If we simplify, we have a slope of negative 1. Take a moment and pause the video and see if you can do B and C. As a hint, for B, you only need to select 2 of the points to be able to find the slope. Alright, so looking at B, we have our change in y over our change in x. I just selected the first 2. It didn't matter which ones you decided to go with. So y minus y1, so 1 minus 6, and then x minus x1, so 2 minus 5. And then we have 1 minus 6, which is negative 5, and 2 minus 5, which is negative 3. You can have negative 5 over negative 3. Negative divided by a negative is a positive. So either one would work, because this is saying go down 5 and to the left 3 from a point, and this one's saying go up 5 and to the right 3. Either way, it's going to make this line. Alright, let's look at C. Alright, so once again, we have our change in y over our change in x. So we'll have 3 minus negative 1 over 2 minus 2. And when we do that, we end up with 4 over 0. When we end up with a 0 as a denominator, it makes the function, or your slope, undefined. So, therefore, it's an undefined slope. Now, point-slope form will help you with a lot of other things. So the equation of a line in slope with a slope of m and a point x1, y1 is as follows. So y minus y1 equals m times the quantity x minus x1. I would make sure you have this formula in your notes somewhere. It's rather beneficial. Alright, so writing equations of lines. In slope-intercept form, write the equation of the line that contains the points in the table. So no matter which formula you're using, you still need your m value. And in this case, to find our m value, we're going to have to find our slope. So y minus y1 over x minus x1. Or we can think of that as 1.5 minus 1 over -3 minus -1. And 1.5 minus 1 gives you 0.5. And then we have -3 minus a -1, so that's like saying -3 plus 1, and -3 plus 1 is -2. Okay, so we have a decimal within our fraction, and you never really want that. So 0.5 is the same thing as saying 1/2, and we're going to keep this -2 on the bottom. Well, you also don't want a fraction within a fraction, so this is the same thing as saying 1/2 divided by -2 over 1, because if you think about it, -2, if you were to make that a fraction as well, you would just put that over 1. Well, when you divide fractions, you multiply by the reciprocal, so you have 1/2 times 1 over -2, which gives you 1 over -4 as your slope. It might have been easier to pick -1 and 1 as well, and 3 over 3 and 0. However, I wanted us to get a chance to practice with some fractions. Now, there are two methods that you can use to solve once you have your slope. So, method 1. Method 1 deals with using the point-slope form. Alright, so point-slope form is y minus y1 equals m times x minus x1. And we would pick one coordinate, so we might as well pick one that has a 0 in it, because that makes our life a little bit easier in the end. So we have y minus 0 equals -1/4 times x minus 3. If we simplify, we end up with just a y on the left-hand side equals -1/4 x, and then plus, because the negative times the negative is a positive, 3/4. So that's using point-slope form. Our other method would be to use the slope-intercept form from the beginning. So method 2, we're going to use slope-intercept form. So we have y equals mx plus b. We need our intercept to make this work because we have an x and a y, an input and an output value that we can use. So to do this, we would have 0 equals -1/4 times 3 plus b, which in the end ends up providing you with b equals 3/4. So then you can substitute that into your equation, and you have y equals -1/4 x plus 3/4. Alright, so let's look at an entertainment application. In the game of Monopoly, a player who lands on a property that is owned by another player must pay rent to the owner of the property. For most color properties, the rent can be modeled by a linear function of the selling price. So let's start by expressing the rent as a function of the selling price. So try this on your own, and when you return to the video, the answer will be revealed. Alright, so step 1, we find our slope. So I just chose the first two to find the slope of them, and we end up with a slope of 1/10. And now we can plug our information into point-slope form and solve for y. And when we do so, we end up with y equals 1/10 x minus 4. So we have now efficiently expressed the rent as a function of the selling price. Alright, so our next step. Graph the relationship between the selling price and the rent. How much is the rent for Illinois Ave, which has a selling price of $240? So let's chart it out. When you unpause the video, the answer will be revealed. Alright, well, when we look at our graph after we've plotted the points and drawn a line, at 240 it's about $20. And then if we input 240 into our equation, and we'll get an output of $20. So the selling price, or the rent for Illinois Ave, when it has a selling price of $240, is $20. Let's look at parallel and perpendicular lines. If lines are parallel, their slopes are the same. So the red line has a slope of 2 and the blue line has a slope of 2. If lines are perpendicular, their slopes are opposite reciprocals. So basically their product is 1. So -3/2 and 2/3. They're opposites and they're reciprocals. So that makes them perpendicular lines. Let's try a couple. So write the equation of each line in slope-intercept form. So let's start with this first one. We know that our slope is going to have to be 1.5 for it to be parallel, because for it to be parallel, they need to be the same. Now, we need to use this point here. So we have y minus 5 equals 1.5 times x minus 4. You have your slope and a point that it needs to go through. So now, to be in slope-intercept form, just solve for y. And when we solve for y, we end up with y minus 5 equals 1.5x minus 6, and therefore y equals 1.5x minus 1. You're going to do the same thing for b, only if it's perpendicular, your slope isn't the same. It's going to be the opposite reciprocal. So if it's negative, it's going to be positive, and then we need to reciprocate it. So it's going to be 4/3. So this is going to be our slope for it being perpendicular. So it's a positive 4/3. And now we just follow our same steps. So we have y minus -4 is the same as saying plus 4 equals 4/3 times x minus 6. So when we start to simplify, we have y plus 4 equals 4/3 x minus 8. And then we have y equals 4/3 x minus 12 when we subtract 4 from both sides. So there you go. And that ends our lesson on writing linear functions.